Hey there, fellow AI enthusiasts. Welcome back to the AI Pulse podcast. I'm your host, Diya, and we're so excited to dive into today's topic. We've all been hearing about the rise of mixture of experts, more models in the AI world. You might have noticed that top performing open source models shipping in production are ditching traditional dense architectures for more. Today we're going to explore why more models are winning over dense models. Joining me is an expert in this field, Mitesh. Welcome, Mitesh. Mitesh, hi Diya, great to be here. Diya, awesome to have you on board. Mitesh, let's get straight into it. What exactly are mixture of experts movie models?
A mixture of experts is actually a really elegant way to solve one of the biggest problems in AI scaling. Think of it like this. Instead of asking one massive brain, a single monolithic dense network to solve every single problem, you route that query to a small panel of hyper specialized subnetworks, right? These subnetworks are what we call experts. Each expert is trained on specific types of information or tasks. So, if I ask the model about ancient Roman history, it sends that token to its history expert. If I ask it to generate Python code, it routes it to its coding expert and maybe a little bit of the logic expert too. The magic happens because of sparsity. The system only activates and runs the relevant experts for that particular input. This means we can build models with trillions of parameters, massive capacity, but when the model is actually running or inferring, it's only utilizing maybe 10 to 15% of those total parameters at any given time. It's pure efficiency. That's why I think it's such a game changer.
Excited tone. Wow, Mitesh, you're absolutely right. Mo is indeed an elegant solution to the scaling problem in AI. And I love how you simplified it for us with your panel of experts analogy. It really helps people understand why this approach is so powerful. Now, let's talk about the benefits of using MoE models. What do you think is the most significant advantage of MoE compared to traditional dense models?
The most significant advantage, without a doubt, is how MoE finally solves the crushing problem of efficiency at scale. It allows us to completely decouple model capacity from computational cost, and that changes everything for developers. In traditional dense models, if you want more knowledge, more parameters, you have to make the entire brain bigger, and when you make the whole thing bigger, every single calculation gets slower and costs more energy. It's a runaway expense. But with MoE, it's different. We get massive total parameter counts. We can dream of trillion parameter models. But because we only activate that tiny subset of experts for any given task, our actual compute requirements per token stay relatively constant. It means we don't have to build these giants in a linear fashion. We can add specialized knowledge without exponentially increasing the hardware cost or inference time. That freedom, that ability to deploy massive yet affordable models is why MoE has become the standard for winning production AI right now. It's revolutionary economics, truly.
Whoa, Mitesh, you're painting a very clear picture of the benefits of Mo, and I completely agree with you. It's indeed about solving the problem of efficiency at scale. Let's talk about the hardware landscape for Mo models. How do you think this changes the way we approach infrastructure and deployment in production environments?
That's a fantastic question because this is where the theoretical elegance of MoE meets some serious real world engineering hurdles. The shift changes everything for infrastructure. Frankly, it moves us from simply needing brute computational power to needing incredibly sophisticated communication architecture. In dense models, you can often try to cram it all onto one gigantic server and rely on massive GPU compute. But with MoE, because the model is so vast and sprawling, spread across potentially many different specialized subnetworks, the challenge isn't just running the math, it's getting the right input token to the right expert instantly over the network. This introduces latency and communication overhead that simply didn't exist before. We can have all these massive parameter pools, but if the router has to spend time figuring out which of those 8 or 16 experts should handle a specific token, or if those experts are spread too far apart on different servers, the efficiency gains get eroded by network slowdowns. So, for deployment today, especially trying to self host these sprawling MoE architectures on standard Linux servers, it demands specialized optimization. We aren't just dealing with memory and VRAM capacity anymore. We're wrestling with dynamic workload balancing and ultra fast inter-process communication. It's a whole new frontier of machine learning infrastructure, a really complex dance, but one that is absolutely worth the effort for the sheer scale it unlocks.
Wow, Mitesh, you're providing such valuable insights into the challenges of deploying MoE models in real world scenarios. It's clear that while MoE offers incredible efficiency and scalability benefits, it also brings unique infrastructure requirements. Let's talk about the future of AI development with MoE models. How do you think this technology will continue to evolve? And what potential applications or industries might be most impacted by its advancements?
Oh, if I had to predict one thing about the future of AI right now, it is that Mo isn't just a fad, it's fundamentally changing how we think about intelligence itself. I believe the evolution will focus heavily on making those experts smarter and more cooperative. Right now, the router decides who handles what, but in the near future, we'll see models where the experts don't just handle tasks, they actually collaborate. The system won't just route data, it will manage a genuine conversation between specialized modules like an internal swarm intelligence. And as for impact, I think the most dramatic leaps are going to happen in industries that require both massive knowledge and profound specialization. Think about healthcare, for instance, and MoE model could theoretically have one expert dedicated solely to analyzing genomic sequencing data, another tuned specifically to interpreting complex MRI images, and a third focused on drug interaction protocols, all within the same unified framework. That level of hyper specialization is almost impossible in a single dense network. Then there's autonomous systems or perhaps even advanced scientific discovery. Imagine an MoE model dedicated to simulating climate change where one expert handles fluid dynamics, another manages ecological feedback loops, and yet another tracks economic variables all simultaneously. It's moving us beyond just prediction engines, Diya. We are moving toward creating truly modular, adaptive cognitive systems. It's going to be a fascinating, rapid evolution, one that will absolutely transform how many of our biggest industries operate.
Wow, Mitesh, what an amazing conclusion to our conversation today. You've painted a vivid picture of the future with MoE models, and I couldn't agree more. This technology has the potential to revolutionize not just AI, but many industries that rely on intelligence. Thank you so much for sharing your insights and expertise with us. It's been an absolute pleasure having you on the AI Pulse.
The pleasure was all mine, dear. Seriously, discussing something as transformative as Mo with you was incredibly engaging. I feel like we barely scratched the surface of how big of a shift this technology is creating, a genuine inflection point in AI history. Thanks so much for having me on the AI Pulse. Keep questioning, keep exploring, and I look forward to catching up with you again sometime soon. Take care.
It was an absolute delight, Mitesh. Thank you for your thought provoking conversation and insights on MoE models. We'll definitely be exploring more of this fascinating topic in future episodes. Before we go, a big thank you to our listeners for tuning in today. If you want to dive deeper into the world of AI and stay updated on the latest developments, make sure to subscribe to the AI Pulse podcast. Don't forget to follow us on social media for more engaging content and discussions. Until next time, stay curious, keep learning, and keep pushing the boundaries of what's possible with AI. Don't forget to subscribe, hit that like button, and tune in next time when we'll dive into another fascinating topic in the world of AI.